Okay, so we are doing a pattern of an oblique prism. This is an older sketch from Basic Technical Drawing, figure 18.7. Let's throw it in the screen here. So we're going to try to create this pattern that I'm sort of outlining here with the mouse. It is a parallel line development. You can see this line is parallel to the next. So A is parallel to line D. Line C is parallel to line D, C to B, B to A. This edge and this edge are the same edges. And that's where you have to sort of focus on creating your opening. We're going to go to the top view. And we're going to sketch. Top plane. Center rectangle. Just going to drag something out. And it's 7 inches that I'm going to use. 5 inches. Okay. That A to A piece means that this is all going to fold in on itself. So A to A we're going to treat in this bottom right corner, as the bottom right corner. We're going to create that, and we're going to offset this. 0.03 is a number I've found works really well with this sheet metals. Parts, I'm going to reverse it. Happy check mark. Grab it quickly. For construction, again happy. Then I zoom in, and I need to create a gap. The gap is so it allows this whole thing to unfold. Okay, and we're going to get out of that sketch. Now an oblique prism, what it does is it's a rectangle above a rectangle, but the second rectangle is offset. So the next thing we need to do is we need to get another plane in here. So we go to Features, Reference Geometry, Plane. It's going to ask you a plane to reference. So I'm going to reference the top plane, right? It's going to ask for a dimension, so I'm going to set it at 8 inches. So it's set. And I'm happy with that. Top view again. Zoom out a little. I'm going to drag this. I'm going to bring this drawing back in quickly. You can see right here there's 2 rectangles. One is the bottom rectangle and the other is the top. I want to click on this plane, sketch another center rectangle, sort of line it up and drag it. I'm going to throw a construction line in here quickly from the center of it to our origin. So it's black because it is somewhat defined, and we're going to call this, try 6 inches, see what it looks like. And these are going to be the same size as they were before. So it's going to be 7 and 5. And you can see that sort of rectangle emulates the rectangle shown in the drawing. Escape for a second, go down here, grab this, offset it. Offset's fine in direction it was. Grab it, construction, and zoom in and make that cut again. Okay. The cuts need to be basically in the same position as the previous one. If you don't, if you put like, say you put a cut over here and you left the other one on the bottom left, when you loft this in sheet metal, it'll give you like a twist in the center. And we'll get out of that. Okay. Now we're going to try lofting. So it's going to ask for profiles. So I'm going to ask for the first profile. Okay. And I'm going to ask for the second profile. And you can see the cut is where it needs to be. Let's go to the top view. Okay. You can also see that it's either inside or outside. So if I go in reverse direction, you see how it grows. Zoom in, make it look a little more obvious. So right now we're outside of the sketch and we're inside of the sketch. Let's see if it's happy with an inside sketch. Didn't like that. Now generally I start with 30 thousandths. Let's try going down a size. Okay, so the kids, yourself, whatever the students, you have to be resilient and follow things through. If I open up that there, the flat pattern, and I unsuppress it, it should give me the flat pattern. Okay, and there you go, there's that flat pattern, so it's parallel. A to B, B to C, C to D, and then D back to A, which is where it closes up. I always suggest that you unsuppress your flat patterns every 2 or 3 times you do features to make sure that this thing flattens. Okay, otherwise you're going to be out of luck. So I'll go back and suppress this. Okay, go to a quick ISO view. I go to the front, you can see it is one rectangle above another, but it's at an oblique angle. The dimensions I used are just to get this thing to work. What I really try to stress is technique to you guys, so you get an idea of how to create this. And then we're going to save. All right. So I'm going to save it as OP. Okay. And it's going to tell me that there's already one there, but I'm going to save it over it. Next thing is we're going to do a drawing for this. So I'm just going to pull up A size landscape. Alright, insert, drawing, model view. Alright. Flat pattern. Let it think about it for a second. Okay. It gives you the radii and where to bend it at. Okay. I don't like it looking like this. I usually try to get like this edge parallel to the ground. And let's see, I'm going to go into here. I'm going to rotate our view. And I'm pretty sure it was 5313. Let's undo that. Okay. So the previous one was 5313. Just bear with me. So I'm just going to draw a quick line. Make sure it's horizontal. And I'm going to measure this angle. 38.87 or 36.87. Okay. So I'm going to grab that again. So you sort of click in here, escape out of there. Click in here, rotate view. 36.87 minus. Okay, now now it looks better. I worked in a sheet metal industry forever and a day. Contractors and things and vendors do not need a lot of information. Okay? Now you can put your critical dimensions for the bends, but one of the main reasons we have CAD is so that we can send files. I'm just going to save this quickly. Okay. If you send this file and the scale comes in a little bit off in someone else's software who's going to take this, either laser cut or water jet cut the outside perimeter, what you've saved it as a DXF and what it comes in over there could be very different. I always tell the kids, students, drop in your overall dimensions quickly, so that when they bring it into their software, they can quickly check that the dimensions are correct. If they're not correct, they can go about scaling it and making it correct. Another thing I like to do is a general note. Okay, so DXF file available. And then native SolidWorks 2015. What that tells the vendor too is that a DXF is available, which is pretty much the most popular. The DXF format is used on a lot of the laser and water jet cutting. Again, you may have a problem with scale, but the other thing is I always tell them what is native for the format of this drawing. Some places have SolidWorks, and they may want to check to make sure that your bend radii and things like that are good and what they're looking for. Save that. If you press Control Tab and keep your finger on the Control key, okay, to go back to this, and let's just go into this feature quick. Let's just edit. Okay, and generally, if the sheet metal is some thickness, in this case we changed it to 0.02, I usually tell the kids and students that as a rule of thumb, make your bend radius half the thickness of the material. Okay, so we save that. So hold Control, hit Tab quickly, it'll bring up everything that's available. Let's bring up that sheet drawing again. Okay, and there you go. If you need to put the bend radii or things like that, you can always go into a secondary 3-view drawing showing critical dimensions, maybe inside or outside, to make sure that this is going to fit in a certain area, especially if you're doing like computer bracketry and things. But that's it for the Oblique Prism.